Saxon Math Course 2. We are in Lesson 56, and today we're going to be dealing with something that's a little bit different, plotting functions. And first of all, you might ask, well, what is a function? Well, a function is something that has an input and an output. Okay, so let me give you an example. You've seen coordinates like 2 and -1, and we've been able to put those on a coordinate plane. The 2 is equal to an x, the -1 is to the y. Okay, there's the y and x axis. So if we go to a +2 over here and go to a -1 on the y-axis, this is our coordinate. Okay, 2, -1 is right there. So whatever we have as an x, this is an input, and then this is an output. All right, that might not make sense yet, but it will, okay? Let's go to example 1, and I want you to notice something. We have a table here, and the table is dealing with chairs. So there's an x, which has to do with tables, and then a y, which has to do with chairs. Okay, so let's just say if we have one table, we have 4 chairs. If we have 2 tables, we have 8 chairs. If we have 3 tables, we have 12. If we have 4, we have 16. If we have 5, we have 20. Okay, let's think about why this one is 20. What's the correlation, okay, the function of between x tables and y chairs? Well, if we have one table, right, here's our table, we have 4 chairs, probably to go around it symmetrically, but it's pretty easy to see. If we have 2 tables, right, we have 2 tables, and we want to put chairs around them. Because the first one has 4, we're going to assume that the second one has 4 as well, which is going to equal 8 chairs. And we can continue on. So we can keep writing tables out. Instead of doing this big work and actually drawing it out, we've made a function box that will tell us what we have. Now, question A says, write a rule in words that shows the number of chairs Jamal orders for each table. Well, I kind of did that with this example. I said that if Jamal orders 1 table, then that is going to equal 4 chairs. Okay, so for every, here's the wording, for every table purchased, there will need to be 4 chairs. So for every table, does that hold true here? Well, yeah, if there's 2 tables, that means there are 4 chairs per table, which means 8, and so on. So there's kind of like a wording explanation. Doesn't have to be exactly like mine. There's several ways to say this, but I'm just giving you an example. Okay. B says complete the function table to show how many chairs Jamal needs to order if he ordered 5 tables. It was this one down here, and I circled the 20 because I filled it in for you. But why is it 20? Well, because we know that every single one of these x's, if it's multiplied by 4, equals chairs. So watch this. 5 times 4 equals 20. 4 times 4 is 16. 3 times 4 is 12, and so on. You can see that. That's a really easy one to see. And then C, it says write the rule of function table as an equation. Ooh, what's an equation? All right. So for function tables, you have an x and you have a y. And usually we like to see this format, y equals something x. That's the general rule. So your function or equation is going to look like this. Well, If y deals with chairs, then it's going to tell us how many we have and what was the number here that we put in, okay? 4x. Or we could say y, which is 4 chairs, equals x divided by 4. Okay, there's several ways to share that as well. But if y represents chairs and x represents tables, how do we do this? Turn the page. I want you to show you something. Okay. Again, you're going to see down the bottom there of C, it says y equals x times 4. And then they have this, or they have y equals 4x. These, all three things here, are saying the same thing. We're multiplying 4 and x. Okay? Both the ones that they give and the one that I give, 4x, without being parentheses here, right? There's no parentheses. It doesn't matter. 4x means multiplication because there's no space in between there. All right, so we're just writing an equation that would demonstrate if these are chairs, how many tables are there? So if I have y chairs, if I have 4 chairs, that means I'm going to have x has to be 1, right? There's my 1. So 1 times 4 is 4. So I know I need 4 chairs, but that means 1 table. So I can figure out what x is. I can find out how many tables I need. If I have this many chairs, I can figure out how many tables I need. All right, those are the kinds of equations that we're going to see. Example 2 is similar. It says the function y equals 2x doubles every time the input is put into it. If we input 5, the output is 10. If we input 10, it's 20. Below is a function table that shows some input-output pairs. Graph all pairs and the numbers on this function. So here's what I want you to see. Okay, they give you this graph. And this graph, obviously, I'm not going to be able to do it very well because I can't draw straight lines. But you get the idea. All right, so I'm just going to draw some here. Bump, bump, bump. There's my graph. All right, right here at this point is 0, 0. Okay, in your input output box, you have the first one is 0, 0. The second one is 1 and 2. Watch this. All right, this is the x, this is the y. All right, this is the y, this is the x. So if we went x over 1, here's 1, and we went to the y up 2, boom. There's our first one drawn to its origin. Okay, what's the third one? The third one is 2 and 4. So if we went over 1, 2, and went up, there's 2. 1, 2, 3, 4. Look at this. And you're going to notice they're all in line here. Okay, so you can anticipate this one, which is going to be 3 and 6. So all you're doing is charting these on a graph, and I want to see these points charted. You don't have to draw a line through them. All I need to see is the points, just like this. And if we kept going up, it would be up here. 1, 2, 3, 4, 5, 6. Okay, so pretty easy doing that. All right, let's go to example 3. One more example here. It says the illustration, and I'm on page 396. The illustration shows the graph of a function. Refer to the graph and answer A and B. Write the coordinates of 3 points on the line that represent a function. So it gives you this graph, right? And basically, there's a line that goes something like this, right through the origin. So here's what it's asking you to do. Okay, of the little squares, okay, that come up here, it's saying find 3 spots. There's one right in the middle. find 3 spots where they intersect. It doesn't matter which one. It's just saying find 3 coordinates. So one that's really easy is the middle one, which is 0 and 0. That's hard to get wrong. Okay, and then you're just going to find other spots on here, whether it's a negative 1 and 2, or if you go up here and let's say, I don't know if this is right, but let's just say that it went over 3 and went up 3. So it would be a 3, positive 3, positive 3. So that would be 3 points that we found on this line. You are finding the points. You are coming up with them. And there's lots of them. There are lots of them. Okay? All right. I think you understand function groups and what they do for us. I hope that this becomes an easy question in your lessons, because they are pretty easy once you get familiar with them. All right. If you have any questions, let me know and I'll be more than happy to answer.